Hi, Chem team. So we learned in class today that chemists can predict the volume of gases produced in reactions. So for example, if a chemist decomposed 51 grams of hydrogen peroxide into water and oxygen at standard temperature and pressure, it would be possible for them to calculate the volume of the oxygen gas that's produced. So in general, if a chemist wanted to find the volume of a gas, they could use the ideal gas law to do it. They just need to know the pressure, the number of moles in the gas, and the temperature of the gas. In our example, we know the temperature and pressure of the gas because standard temperature is 273 Kelvin and standard pressure is 1 atmosphere. And furthermore, we know that the ideal gas constant with the units that we're using is 0.0821. However, we would still need to know how many moles of gas we would be producing. And we're not told that. Instead, we're told how many grams of hydrogen peroxide we are starting out with in our reaction. So what chemists would have to do to predict the size of the oxygen is they would have to first use molar mass to convert grams of hydrogen peroxide into moles of hydrogen peroxide. And so because there are 34 grams of hydrogen peroxide in 1 mole of hydrogen peroxide, chemists could figure out that we have 1.5 moles of hydrogen peroxide to start out with. But that's just what we're starting with. If chemists wanted to find out how much oxygen we're producing, they would have to use the ratio in the equation to find out how many moles of gas are being produced. And so in this case, we know that for every 2 moles of hydrogen peroxide that we use, we are making 1 mole of oxygen gas. And so if we start out with 1.5 moles of peroxide, we would end up with 0.75 moles of oxygen. So now at this point, we know how many moles of gas are going to be produced, 0.75 moles of oxygen. And so we can solve then for the volume. So we divide both sides of our equation by 1 atmosphere, and we'd find out that the volume of gas that's being produced would be 16.8 liters of oxygen. So this type of problem follows a very similar pattern to stoichiometry conversions that we've done previously, where we start out with grams of some known chemical, convert it into moles, and then use the equation to convert moles of our known chemical into moles of the chemical we're trying to find out about. However, instead of figuring out how much the moles of our product weigh, figure out how many grams they weigh, instead we're using the ideal gas equation to find out how much space they take up, how many liters. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.